Mr. Qualls, what we're going to do is this morning is talk about the volume of prisms. I'm going to make two videos for this. One of them is going to talk about how to use formulas and solve the volume of these different types of prisms, whether they're rectangular or triangular or trapezoidal. And then I'm going to make a separate video that actually addresses the setting up of the problems themselves, which formula to use, and we seem to have a lot of questions and we struggle with that kind of idea, so that's what the second video is about. The first one here, I'd like to just say, we're making really good progress on this, and you guys are going to finish the curriculum this year, which is awesome. That's the goal that we set up at the beginning, and we're going to hit everything this year, which is, I'm just very, very happy about that. Pleased, I'm proud of you guys. And this is a point in the curriculum where we're looking at the area and the area of a circle, the circumference of a circle, the area of all the rectangles and triangles and trapezoids, things like that. And now what we're going to do is we're going to change to volume. And volume is very easy if you realize what is going on and make sense of the numbers that we're using. All we're doing is taking the idea that if we can find the area of this face and then extend it through the figure or extend it through the problem through multiplication, we'll have our answer for volume. Here, if we find the area of this triangle, which is half of the rectangle that would have been there, so we find our length times height, and then we cut it in half for the triangle, and then extend that through the rest of the solid, we will also have the volume of the problem. So today what we're looking at is we're solving real world and mathematical problems involving area and surface area and three-dimensional objects, but we're also extending this into volume. So we're also extending that into volume. So I'm going to write volume on the bottom of that. La, 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 la. Volume, what a cool word. And then, if you look in our text and our curriculum guides, this is what we're looking at here is structure. However, this is really what's going on, because you cannot do these without modeling, all right? Or I can't anyway. I don't want to talk about it. We're also going to use a little bit of structure to solve our problems, and then we're going to make sense. We're also going to make sense and persevere through the problems. Many of us struggle with multi-step problems because they are multi-step. Well, I found this, now what do I do? Or, somebody looks at the very end of the problem and a lot of us just stare at it. And I was like, if I stare at this long enough, I'll probably figure out the volume of this problem. And that's not how you develop your thought process, your problem solving processes. There should be a method to your madness. There should be a method, and you should go along with, this is how I solve these problems. I draw my picture. I decide what formula I'm going to use. I'm going to decide on what variables I know. And then I'm going to take the variables that I know, the quantities of those variables I know, and I'm going to substitute those into the problem. And then the formula, through orders of operation, tells me how to get my answer. We don't use formulas because, they're a pain in the neck, or just like, this is just more work and make things harder and more difficult for us. They actually make things easier because formulas tell you what to do. I could give you a formula for something that is just crazy, like the amount of jet fuel that a rocket is going, or rocket fuel that a rocket's going to need. And you have no idea what to do anything with rocket science. And I should be able to give you the formula for how much fuel you need for a certain trip or something like that. And if you know how far the trip is and how heavy the thing is and what the gravitational forces are, you should be able to plug it right into the formula and figure it out, because that's what formulas do. They tell us how to find answers, all right? So what we're going to look at here is our volume. Now, this volume problem, typically what we have with a volume problem is a length. So we have a length, and then we have a width of the thing that's on the bottom, right? So let's go with a length and a width. Let's put my width over here, and I'm going to explain this in just a minute, length and width, and if I multiply length times width, this is actually the area of the front of this. So if, let's say, length was 3 and width was 4, that means that this is 3 wide and this is 4 tall. Well, this drawing's working out a little better than I thought it would. So 3 times 4, so this is 12. So this would be 3 here, and this would be 4. And so my area of the front of this thing is 3 times 4, or 12. Now, what that really means is these things are blocks now. They're squares on the front. But when we're talking about volume, they also have a depth. And the depth that they have, well, I just can't get that thing to stop ringing when I'm on video, can I? Okay, I'm just going to keep going. So these things have a depth of 1. So if we wanted to know how many cubes are there on the front of this thing, it is 1. The depth is 1. So it's 3 times 4 times 1, which is 12. So there's 12 pieces on the front of that. The reason that we didn't have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm glad that worked out. But the reason we didn't have to add these is because this is 3, 4 times. And if we added 3 plus 3 plus 3 plus 3, 3 plus 3 plus 3 plus 3 is repeated addition, and repeated addition is multiplication. So 3 times 4 is going to be 12. Or we could look at it this way. There's a group of 4 here, and I have 3 of those groups. 3 groups of 4 is 12, because 4 added repeatedly 3 times is 4 times 3, because repeated addition is multiplication. That's what multiplication is just a repeat of the same number, a repeated addition of the same number. So if I want to know how deep this thing was, I would have to know how many of these rows there are back into my, how many rows are there back into this? Well, let's say that our depth, okay, our depth or our length, our width, and now we're going to call it a height, even though it's laying down on the side, okay? But all I really need is an idea that there is a third dimension going back here. So if I say that this is 5, and this is going to complicate my picture a little bit, but I'm just going to do it anyway. Now what we have is we have 4 more rows of this, all right? We have 4 more rows of this going back because we had 1, but now we need 5. And then when we go back here like this, now, man, look at all that. I mean, how much would it be to count all these things all the way back there? Well, I'm not going to have to do that because now I have a group of 12 in the front. I know I have a group of 12. I must have a different color marker here. So I've already counted this group up front. Okay. And I've already counted my group up front. And I know that there is a group of 12 in the front. And if I had 12 up here on this first layer, well, how many layers are there back? Well, it would be 12 plus 12 plus 12 plus 12 plus 12, which would be 5 12s. So, and if I repeatedly added 12, that is what multiplication is. So if I had 12 here, boom, 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 boom. So there's 12 and there's 5 of them. All I really have to do is multiply this by 5, okay? Which 12 times 5 is 60. Now, 12 times 5 is 60. There are 60 blocks in this thing. So what I've done here is I had a group of 3 and I multiplied it by 4 because I had 4. It was 4 tall. And then I took that idea 12 and I pushed it back, okay? So 60 is 3 times 4 times 5. So what I had was a length times the width times the height, and length times width times height is volume. Okay, so I've taken my idea of a length and a width, which is my face of this first side, and a depth of 1, so it's only 1 length or one deep, and then multiplied it by my height, which is back 5, okay? And then got my 60. Now, that is how this works. If we look at this this cube that we were messing with before we left school, we look at this, I've got something that is 2 wide, 3 long, and then it's 4 tall, all right? So if we want to know how many cubes there were on the bottom of this thing, it's 2 times 3. I don't have to count because it's 3 groups of 2 or 2 groups of 3. And that is what makes the bottom face, all right? Or the bottom layer. So when I'm looking at this bottom layer and I want to find volume instead, I'm concerned with my length, my width, and then my height, okay? So this is how this works. If we want to know how much is in this bottom, we already know that. There are 6 in there. There are 6 in that group, okay? There are 6 on the bottom. And then if we counted it 3 more times, because there's 4 groups of them, there's 1. So 6 plus 6 plus 6 plus 6. Well, 6 plus 6 is 12, plus 6 is 18, plus 6 more is 24. Now, how can I count that that is actually, how can I figure out that that's actually 24? Well, this was 2 times 3, which is 6, times 4, which is 24. So I know that there are 24 cubes in this rectangular prism. Length times width times height. It's 3-dimensional. And that's why we call things cubic when they are cubic in measurement. So I would have to put, since I didn't have any measurements here, I would just put units cubed because it was 3-dimensional. All right. Now what I do for the triangle? The triangle is a little more complicated. So what I need to know is, just like I figured the face of this thing, what I have to do, I figure this base, we're going to call this thing base, big B for base, all right? Big B for base on this thing. We figured this thing out and then we pushed it through the rest of it. So now what I need to do is I need to figure the base of this triangle. So I'm going to calculate the volume of this triangle. And let's say we knew that the height was, let's make it 6, all right? And let's make the width of this thing 4. And then let's push it back, 8. Okay? So now, there's a lot of tricks that happen with this stuff. Somebody will put a 5 over here. And do I really care how long that side is if I want a length times the height or a base times the height on this? No, I don't. I don't care about that. So what we're going to look at here is I need to know big B, which is base. And then I'm going to multiply it by the H, right? I'm going to multiply it by the height. And the reason we call that the height in this situation is if we set this thing down and this thing was on the bottom, all right? So the book is doing things a little differently than I am right now, but we will eventually get back to what the book is talking about, okay? So what I want to know is I want to know what one layer of this thing looks like. I want to know how many blocks or how many cubes there are on the front, the very first layer in this triangle, all right? We're going to dot that. So I want to know how many there are in the first one. And then from there, I'm going to figure out all the way back, okay? So I'm going to start with my volume idea. And in order to find my volume, I need to know what the area of this, or the area of the front is. So the area of the front of this is 1/2 little b base times the height. And then once I find the surface area here, I can push it back into the other section, which we're going to call this 1/2 base times height. And for right now, I'm just going to call that, a length, okay? I'm just going to call it a length for right now. So what I need to do is I need to figure this out. And I'm going to put I figured out my formula. And this section right here is my triangle, and then I'm going to multiply it by that, okay? So I need 1/2 base times height, the 1/2, and then the base is 4, and the height here is 6, all right? And then we're going to multiply it by 8, because that's how deep this thing goes, okay? So 1/2 of 4 is 2. So this becomes 2 times 6 times 8. Let's see. This is, I can do this in any order I want to. You know, I'm not too cool on what 12 times 8 is, but I do know that 6 times 8 is 48. And 48 times 2 is 96. And let's say there's centimeters, okay? So if it's centimeters, then it is centimeters cubed, all right? Now, in the book, if you're looking in the book, they do the triangular prisms a little differently. They put them like this all the time. Oh, let's see, how can I draw this? They put them like this. Okay, and that might be a little off there, but what they do is they have their triangle down here. Okay, they have their triangle up here, so that when you find the base, and they talk about big base. The big base is this bottom piece down here. Okay, the base is the bottom of the triangle, or the triangle that sits on the bottom, and then they use this as the height. Now you can get confused on this because when you find the area, the surface area of the triangle, this is referred to as base and this is referred to as height. So what they're doing is they're calling this thing big B for base, and then they're calling that height. This height and that height are different, but it's a matter of making sense and using structure and making sense of your problem. So if you're going to be confused by this, what I would do is something like this. Find the front, my triangle, and then multiply it through. All right? So I think I hit everything I needed to hit here. And so that's the end of this video. Volume is very, very simple. Length times width times height. Or find the surface area of the triangular side, or the trapezoidal side. If it's like this, and it's a trapezoid, and it goes back, what are you going to do? Well, we're going to find how big this front piece is, and then we're going to multiply it back. So we're going to find this, which the area of a trapezoid is going to be, this is your base 1, and this is your base 2, and then we need our height. So we're going to add base 1 plus base 2, and then we're going to divide those two to find a mean, or to find a mean between the two of them, and then we're going to multiply that by height. And this is going to be the surface area of that, but it also represents the first layer, and then whatever that is, and I'll just call it W for now so we don't have to use another height, and we'll just push W back that way, and this times W is going to be the volume of the trapezoidal prism. All right? Doesn't matter if there's a hexagon or if it's round or whatever. If there's an oval out front here, which you guys aren't going to be messing with until next year. But it doesn't matter if things are round out here, if they're curved, whatever the front face is for a surface area, if we push it through and multiply it by that other, we'll have the volume. Because volume is just multiplication of three ideas. The length and the width, and then the height, or the height and the length and the width, or whatever three numbers you're messing with. Okay? Alrighty. The other video shows you how to set up the problems that are on the assignment.